Cool. Look at the maximum subarray problem. So from the New Year's curated list, should be maximum subarray right here. So given an integer array nums, find the subarray with the largest sum, and then return its sum. So we'll look here at the example. 2, 1, -3, 4, -1, 2, 1, -5, 4. The output will be 6. The explanation being the subarray 4, -1, 2, and 1 has the largest sum 6. So essentially, from an array, we're gonna go and go through it, and keep track of any subarray, any sequences, and we're just trying to find what is the longest continuous sequence of values inside the array that will produce the largest sum. This one was pretty hard. I tackled it the first time. Let me go ahead and switch here. Cool. So, okay, so I've already set it up inside IntelliJ. So here it is, the problem. And then let's go, as always, figure out how we're going to tackle this one. So we're going to do for each value in array. We're going to have to go through it. And then we're going to keep track of the sum of each subarray. Okay, so the easiest one to do would be to do a double for loop, where you go from left to right, right to left, and then you'll be able to get all the products going that way. So let's go ahead and do that. So we would go for, cool. So like we do for each value from left to right, and then we do for each value right to left, and then we're gonna go ahead and keep track of that value, the running total. So like we would start from -2 side, be the outer loop, so be -2, and then the other loop would start at 4, right, to be 4, then plus -5 plus, so it'd be 4 all the way to 2. And then from there, we could also go again to -5 all the way to 2, 1 to 2, and then so forth. So it's going to be for each value from left to right, for each value from right to left, and then we still need to go and iterate through it. So yeah, actually might have to be a triple loop, right? Because we could do like this, and then do for each right to left target. So it's nasty. It's not really a nice way of doing it. And usually I'll set up the brute force ways to solve these problems, but this specific one is more so to test if you know a specific algorithm, Kane's algorithm. Essentially what we're going to do instead, let's go and just try to work it out. Like, what are the thought processes you should go about it? Well, we could do all those for loops. It's just such a nasty piece of code that I'm just not going to go ahead and write it. Because the amount of work needed for it is so much, and like with the previous videos, it's not a solution you ever do, right? Because it'll be like, oh, n of 3. Even O(n) squared is just going to be such a large value that it's just not worth it. You know, it'll have a timeout issue, and you'll never actually use that solution. Honestly, I don't think it really shows much like brute force. But in an actual scenario where you're doing an interview, you should at least try the brute force if you can't think of anything else. And usually the interview will kind of nudge you in the right direction and say, hey, we got them, I did it this way or that way. But if this specific one, I'm just going to jump right into the actual optimized solution. So what we're actually going to do is we're going to go and create 2 integers, right? We're going to do integer, or actually let's call it max sum seen so far. And we'll call another integer, we'll call it max sum at this index. This value will be the maximum sum we have seen in the array. We'll see another value to compare to. So max sum of this index. What this actually means is, what is the maximum array value or array sum I can get at this index? If you have an array, let's say 1, -1, then 2, right? Like we know looking at it that the maximum subarray is right here 2, and it'll be 2, but we have to actually walk through it, and code it out. So as we're going through it, right, the first one will be the max value. Max will be equal to 1. Max is equal to 1. Max at the index is also equal to 1. And then for the second evaluation, max is equal to 1. And then the max at index, what we do is we will get the value, a value of max index itself, plus the value at that current cell, which is -1, and that will equal, that goes to 0. So then what we're going to do is we're going to evaluate, is max greater than index? Actually, we're going to do max is equal to the max of max and index. So basically what this is going to return is returns largest value. So we could pass in 2 values and it'll go ahead and return whichever one's the biggest one. And the reason we need this is because we need to keep track of the running total. But essentially, as you're expanding the array, you want to think of it as a sliding window where you only know the value you're at. You only know the value you have already seen, right? So then the first iteration, you only know the first value, and then out of these two, and then out of these two, we know that the largest sum will be 1, and we know that the sum of these 2 cells will be 0. And once we get over here to 2, we know it's be 1 minus 1 plus 2, which is still 2, largest value we've seen so far. That'll go ahead and override it. So let me just show another use case, well, another edge case, where we're gonna have, let's say, -2. So at this point, max equals 1, index equals 1, and index here being max index, and then max equals 1, index value is gonna be -2. So then we're gonna do max index will now be equal to max index plus the current index, which is -2. Yeah, and then from here, what we're going to do is we're going to do max is now equal to a maximum of max and max index, which is going to be what the max value between 1 and -1, which will be 1. So our max value is still seen as 1. Our index right now is actually -2. So for this type of use case, what we're going to do once we get to the third spot, max is still 1. Index is equal to 2. So here max equals 1. Index equals 2. Max index is equal to itself plus plus 2. Right, so we at this point we also know that max index will be equal to the previous max index, which was -1 plus 2. So that sets it to 1. But here we need a validation step. Is current index bigger than the max index so far? Right, the max index so far. If it is bigger, max index will now be equal to current, and else we're going to go ahead and continue, keep on the usual. So the logic here being that this right here, -1 plus 2, what it actually means is from 1, -2 to 2, right? Because the way we got -1 was adding these two. So what we're doing here is we are comparing. So what we're doing here is we are comparing the current subarray with the current index versus current index. Right, so it'll be 1 minus 2 plus 2, and we're going to go ahead and compare that to 2. Right, and then if we compare it, it'll be 1 compared to 2. So we know here that 2 is larger than 1, so max index will be equal to current. So the reason we want this is because we want to see if adding this number to the current subarray we have is bigger than or less than the current one. Because if we add this 2 to this array we already have of 1, -2, it's not going to do anything, right? Like, it's going to go ahead and be lower than 2 itself. Because 1 minus 2 is -1, plus 2 is just 1. But this value here 2 itself is actually bigger. So let's go ahead and code that out, and then I'll go ahead and walk through some steps. Cool. So I have here set 2 variables. I have max sum seen so far, which is the max subarray value we have seen, and then max sum at this index. So the max subarray value with this current index. This one represents if we have done any resets because the current value is bigger than current subarray, or if we keep adding values to the subarray, what is the running total? You also think of like a running total value. So let's go ahead and code that out. So we're gonna do a for loop. We're gonna enter iterator is equal to 1 because we're gonna start 1 to the right of our current value. We're gonna do iterator is less than num.length, and then just the regular old plus max sum at this index is gonna be equal to, and we're gonna import the math function here, math.max, and we're passing 2 values. We're passing nums at this index, and we're passing in iterator, and we're also gonna pass in, then we're gonna pass in itself, because max sum at this index plus nums at the current position. So this is going to go ahead and returns the largest between current sub right with this value index or index itself. This is easily represented with the this is probably easily represented with the easiest one here would be the 1, -2, 2, where if we're comparing 1, -2, 2, which is equal to 1, or we're comparing it to 2, which is the index value over here. But we'll get into that as we keep going through the loop. And then we're actually going to go ahead and update the global max value seen so far, which is this over here, max value seen so far. And this is not going to be equal to, once again, math.max value of the max sum seen so far, and then the max sum seen at this index. We do this because once we're evaluating, like up here, right, max index is equal to 2 at this point, at the last cell right here. We need to evaluate, is this new value larger than the max we've seen so far? Because up to this point, the largest value we've seen is 1, right? Because it's 1 here, these 2 is -1, over here it's 2, 2 beats out 1. So we're just adding this check here to make sure that, hey, if our new value beats out our old value, let's go ahead and update that. And if not, we just continue as normal. And then at the very end, all we're going to do is return the max sum seen so far here. And that should be all this. Cool. And then just to run it down one more time. We initialize 2 values at the beginning, the max sum seen so far. Right, so basically our largest value, and then the max sum at this index. This one being the max subarray we have seen so far at this current index. And then from there, we go ahead and iterate through the loop. We start 1 off from the first one, because for the first value, we don't want to go ahead and add it back in. So we're just starting 1 to the right, and then iterator through the list, and then max sum at this index is either going to be the current value or the current value plus the max sum of this index. Here. This right here basically being like, hey, if you have a subarray, let's add this new value, right? So you can think of it as, you want the max between 2 or 1, -2 plus 2. So between these two, which is the maximum value, and then from here you just do the simple mathematics and you're just evaluating 2 or 1. And then here it's the value 2. Yeah, so it's going to update 2. And that's why over here, with the max value seen so far, it's just going to be the maximum between 2 or the maximum at this index. Sorry. Then over here, it's just going to be the maximum we've seen so far, which is just 1 compared to 2. And that will give us the value of 2. Cool. Let me copy this over to leak code and go from there. Alright, back in leak code, let me paste that in and submit. Cool, 1 millisecond and it beats out 99.64% of users. Cool. This was a pretty difficult one, and I'll be honest, it's not one I would be happy seeing with, even if I had put in some time to work on this one, because this mostly tends to be one of those problems where you either know it or you don't. And it's a little hard to actually find an optimal solution if you don't know what you're doing, or you haven't really seen a problem like this. Usually with most other solutions, you can at least do a brute force and then try to go from there. But this takes some more thinking of like, okay, cool. Set up the array. Okay, let's add the values. Oh, how do we reset? It's a bunch of different things where I don't think this is a good question to see in an interview. Yeah, this one really just says, hey, you either have basically, this one is basically just, hey, have you been studying leak code? Have you been working on leak code? You know, working at it? Or I don't really feel this is one of those questions that really, I feel it's really one of those questions that really tries to see how you're thinking about it, because it's not really thought about this one if you've done it before, right? You don't really get to think about it, and it's one of those niche questions where, you know, you either know it or you don't, right? Like, okay, cool, I'm using max, try to see between these two values. Even looking at this code, right? I've done it, but looking at it, it's still ugly to me. It doesn't really show me anything. Right? It's one of those questions where, you know, if you know what you're doing, one of the questions where if you know it, cool, good for you. If you get it, you know, all set. But even then, honestly, I think I'd be honest with the interviewer and tell them, hey, I've seen this question before. I don't want me to advance, right? Do you want me to still do it? Do you want me to do a different one? Because yeah, I think part of it is too, if interviewer you have a question, they'll be able to tell if you've seen this already. And I think honestly goes a long way. We're telling them, hey, I've done this before. I kind of know how to do it already. You know, it doesn't really hurt you to be pretty straightforward with it. Because if you already know this question and you already know how to answer it, it's not really a good assessment of your skills or how you're going to go ahead and problem solve. But yeah, any comment, question, concern, leave it down below. Any specific question. Sorry, this one was a little rushed. Just been busy with work today. So yeah, see you next time.